Hey there, everyone. Welcome back into our Hangout series. James Hilliard back with you. And I want to share a couple of thank yous. First off, to all of you that have joined us for the Hangouts as part of Innovation for the Nation. Also, big thanks to the Google Enterprise Government team, the great government transformers that we've had on board here, sharing some really great stories, getting us thinking about how we really can use Google technologies, work with partners to really impact change within our organizations out there. Big thank you to our partner companies as well. In the last housekeeping notes I want to share with everyone, we're going to keep the virtual environment open for about 30 minutes after our closing keynote here. During that time, I invite you to, again, get back to the partner booths, the Google booth. You can download more white papers, case studies that are available to all of you. And I ask you to find the survey under the survey tab there. Give us some feedback about this presentation, about the virtual summit, and also let us know if you'd be interested in more of these. So share your thoughts there. With that, my pleasure to welcome Google's Chief Technology Advocate, Michael Jones, to our event. He is one of the original co-founders of the technology that is today known as Google Earth, and we've talked a lot about that throughout the 2 days here. Michael's going to be sharing with all of us how we can harness the rapid pace of technology innovation, put it to use at your agency, also share just some general insights where Google believes we can all be moving towards in the future. So, Michael, with that, welcome, sir. Appreciate your time today.
Thank you. It's great to be here with all of you. And I want to talk to you today about the Google view of technology. And that's important because what you've seen over the last 2 days is things that you can do with technology. And I want to talk to you about why we built tools that made that possible, what we think that power will allow in the future. And for me, it's really about the power to transform. And I'm going to show you some examples of that. Let's get started right now. At Google, everything we do, every decision we make, every thought flows from our company mission. And that is to organize the world's information and make it universally accessible and useful. And I want to just take a moment to make you understand that that's very, very important to us. We talk about that every time something comes up. Every debate with Eric or Larry or Sergey or the board of directors is about, well, does this really advance that cause? Does this make people better informed, help them make better decisions, help them lead better lives? Does it lead to better government? Does it help us understand our planet? These are the kind of questions we ask ourselves. So we take all these words as being very important. So organize means to make really useful in a way that you can find what you're looking for. The world's information isn't just like web pages. It's all the world's information. It might be information about the stock market, about patents. It might be information about the temperature on Venus. It's like all the world's information. How do you make it universally accessible? And universally means people in their bicycle, people on their phone, people that speak Swahili. Universally, people that are blind, means everybody. And the useful means that you can really understand it. So, for example, if you had a library where all the books were sorted not by Library of Congress number, but by, say, the color of their binding or the typeface, all the Helvetica books on one side and all the Times Roman on the other side, that would be organized. It would be useless. We make it useful for the whole world. So that's what we think about all the time. What that means is we need to make it possible for people to access the information. It has to be captured, recorded, and be able to be recalled on demand, wherever you might be. We want to facilitate your understanding. So we make it so in Google search you type define diamond. It'll tell you it could mean a baseball infield. It could mean squeezed carbon. It could mean a variety of things. We help you understand what you're seeing. It also means to lead to action. And that's one of the big parts of what we do that's particularly important for enterprise customers because they're in business. So I think this is a big part of what it means to our government customers because they take action on behalf of their citizens that they are there to protect and serve. So those actions are very important. I'm going to talk about that. So we want to make the world's information useful and, in your case, actionable. And the way we do that at the global scale for the whole planet is to look at the problem differently than other people have, and perhaps almost seemingly irrationally. But here's what we do. We say, look, there are billions of users. Of course there are. There's 7 billion users potential for us. There's 2 billion we see every day. So then how do we deal with that? Well, they have different kinds of devices. They don't all have the same device, the same web browser, the same phone, the same anything. They don't speak the same language. They're just all different. And so some can write, some read right to left, some read left to right, some read top to bottom. So it's all different. So we just accept there's a mind-boggling diversity of users. The idea of lots of processors, that's really important too. The kind of computations we want to make possible only possible with millions and millions of computers. And in fact, if you think about billions of telephones, those are part of the solution. So there's billions of processors there. So there's already billions of processors. There's lots of data. If a PC could have a terabyte disk, so you could have billions of PCs. So you've got basically trillions of bytes, trillions of bytes of data that's there to be dealt with. And if you imagine a billion processors, trillions of bytes, that would be pretty hard to move around in a bus or a wagon. So you pretty much have to leave that at home and connect it together with a network. So we're committed to the network, the processors, the users and devices and everything. So we start with that as a configuration. And when you start realizing that's important, then you design things differently. You don't design things to fit in the same chassis, to run with the same operating system, just run with the same power. You start out thinking, that's never going to work. I've got to build a meaningful aggregation of disparate devices that I have no control over. And that's a humbling starting place. It makes our job a lot harder, but it makes it possible to scale to serve every human. Alan Kay said that point of view is worth 80 IQ points. I talked to him recently, and when he was in Xerox PARC, he always said that if you looked at the problem the right way, even an average person could do better than a genius if you just knew where to look. And so we start by looking at the problem this way. In 1975, 1978, 1980, there was this vision that there would be a PC on every desktop. That's all right. The idea there is actually not so different than what we're talking about. So if you take those billions of users and make it be one user, take all the devices they might have now, like game platforms, telephones, glasses, computers, and make it just be one thing, a keyboard and a monitor, and you make the processors not billions but one, and the disk drive, the data be not trillions of bytes but just one disk drive, then basically the network can be replaced with a motherboard. It goes into a box. It's called a personal computer, and that's pretty standard. There are more than 1 billion of those, and they're great. I like them myself. They're great. The problem is the quality of problems that we need to solve now can't be solved with one processor. They can't be solved with enough disk drives that can be driven by one 110-volt power line, right? The kind of thing we want to solve it where you're not chained to your desk. You're free to move. We want to unshackle people so the solutions they need are available wherever they happen to be. And that's worked for us. We like to introduce some of the Google billionaires. You might have heard Google billionaires. These are the 5 billionaires at Google. These are the 5 products that have 1 billion users every day. So we have 1 billion people, more than 1 billion people do Google search every day. 1 billion people have Android devices around the world. Every day, 1 billion people use Google Maps to find a location. Well, every day, more than 1 billion people look at a YouTube video. More than 1 billion people have installed Google Earth on their computer. I started with my 3 friends of mine and I at my desk in my dining room. Now it's on 1 billion people's computers. That's the scale that when I say billions, it's not a made-up number. It's an everyday truth for us. To do that, we need, maybe not billions of processors, but we need millions and millions of processors. We need billions of processors helping us that are in phones and mobile devices, that are in forward edge caching servers and everything else. This is the inside of a typical Google data center. What you see there is half a data center. So you see about 50,000 cores, CPUs there, each of which can be multiple cores. So what you may not know is that whenever you do a Google search, like if you type in where is the car return at Dulles, you hit enter, and it comes back in just a fraction of a second, thousandth of a second, 10,000th of a second. You've just done a search on 20,000 CPUs right there. You've done one of the largest supercomputer applications you'll ever use every time you do a Google search, even when you do it from your phone. And that's what's possible because the computers aren't where you are, because the network is reliable. It's between you, it's somewhere else. The data's somewhere else, the computers are somewhere else. And here's an example of that. I went to this website. It's the Munich newspaper. It's got some interesting looking stories, but unfortunately, I don't speak German. So fortunately for me, my Chrome browser said, hey, that's in German. Do you want me to translate that? I said, sure, translate that. Instantly, it's replaced with the same paper, the same stories, but translated to English and reflowed. The bullet points at the top are now in English. It's fantastic. And I could have picked Swedish. I could have picked Chinese. I could have picked Russian. So in Star Trek, Lieutenant Uhura had a thing in her ear, kind of like I have, where she could hear people in whatever language they spoke in her language. It's called the Universal Translator. What you're looking at here is a big part of the Universal Translator. There's a phenomenal amount of computation required to make that happen. We did that by looking at all the documents in the world and translating, doing parallel translations. We do that on tens of thousands of CPUs when you hit, yes, translate that. So that's not possible at your desktop. The computer power you need to solve these problems is not available at your desktop. And you see that in cities where they want, for example, to have immigrants to be able to read the laws and instructions in whatever language they come in. Well, you can only do so many languages. There are thousands of languages. But with us, we do it for you automatically. And you can even make that be automatic by clicking on Always Translate, in which case it's as though you always speak German. So I think that's something great. Something else we did that leverages that power, something called Google Goggles. And this is a kind of a what's the future going to look like? It's going to be poly-language. It's also going to be visual as well as textual. So here, this is a product you can download for your phone, install this on your phone, not for a BlackBerry, unfortunately, but if you have a modern phone, so to speak, you install this thing on your iPhone or Android phone, and what you do is you take a picture of things. And you take a picture, say, of a painting, then suddenly the painting is it tells you at the bottom, this is painted by so-and-so. You take a picture of a box of raisins, it'll say, oh, I looked at the barcode, I recognize that as a barcode, I looked it up, and it's raisins made by this company. And if you look at a menu, you're in Russia, you're hungry or thirsty, you take a picture, and it says, oh, I recognize that. That says hot drinks, tea or coffee. Well, that's really good to know. I mean, I don't speak Russian, but I get thirsty like anybody else. So that kind of information about what you're seeing that you don't understand is now always available to you. And in fact, I'm going to explain that even better with a video. Take a look.
Hey, I'm Casey, software engineer at Google, and today I'm going to try to beat a Sudoku master at her own game. Or actually, this phone's going to beat her using Google Goggles.
Go.
Is this alright to you?
Not bad.
What I like about that is not that it solved a Sudoku puzzle, but that by taking a picture of a Sudoku puzzle, just a regular picture, not straight down, but just kind of aiming at the puzzle, the Google Goggles and Google servers were able to figure out that looks like a grid. It's got numbers in it. It's 9 by 9. I bet that's a Sudoku. And it figures out that it's a Sudoku. And then it figures out what the numbers are. And then it says, do you want a hint or do you want me to solve it? And so imagine a world where taking a phone, take a picture of a sick baby, and the phone could tell you, we could tell you by talking to doctors, is that an important rash or not an important rash? Is that a bad cough or not a bad cough using sound? So this kind of searching, not using text, can be incredibly important and can rely on a lot of insight that happens somewhere else, even solving a logic puzzle. Only works, though, if the computers are really reliable. So here's some examples of pictures of some Google data centers. We've got pretty high uptimes, even though data centers, things can go wrong. So here's an example of what can go wrong. Giant meteor came, took out the dinosaurs. It can take out a Google data center too. But what we have to do is we have to have reliability even in that case. So we need to have networking that's so redundant and so diverse that we can always automatically fail over all the time. Have your data replicated in multiple data centers all the time, so that you never lose data no matter what happens, even if you have like 2 meteors at the same time. And the problem with that is that that's great for data centers. It's great for commercial data. What about our users who need to access data wherever they may go? And we have an answer for that too, and a video. Let's take a look at it.
Sometimes
Everyone isn't really everyone. Like when people say, everyone's on the internet, because the truth is, for each person that can get online, there are two that can't. And when you look closer, that everyone looks even less like everyone. In some places, it's more like 1 in 1,000. In others, it's 1 in 10,000. And in some places, no one's online at all. But what if there was a way to light up the entire globe and finally make all the world's information accessible to all of the world's people? Well, even though today 1 in 3 kids can't get to a real secondary school, everyone could have secondary school come to them. In places where there aren't enough doctors, everyone could be helped by doctors in other places. Farmers everywhere could start using better weather data, so everyone could enjoy a bigger harvest. And because small businesses that are on the internet grow twice as fast, everyone could create new opportunities for everyone. But how do we bring affordable internet to everyone? Maybe finding an answer starts with looking somewhere new. Like up, and trying something different, like balloons. Yep, that's right, balloons. Because it turns out that if you use balloons, it's faster and easier and cheaper to give everyone the internet than it is to give some people the internet. That's why we're giving it a try, and why there's hope that someday soon, everyone really will mean everyone.
So that's called Project Loon, L-O-O-N. You can search for that on Google. What you have, and you see in this picture, is a high-altitude balloon that floats in the stratosphere that uses sunlight on the upper surface of its lower platform there at the bottom to generate power that provides internet access to people down below in a 30 or 40 kilometer range. And it can float in the stratosphere. We can use power on board to raise and lower it, so it can use different stratospheric wind directions to control its location. And it can also talk to other balloons. So you imagine a grid of those all over the world floating around, talking to each other, to provide global internet access to people at reasonable cost. So that's a pretty extreme thing to be working on. We've got these flying right now in New Zealand. We're doing tests in California. And someday there really will be internet for everybody, whether we do it or somebody else does it. We're willing to go first on behalf of the people who can't vote right now, the 2/3 of humans who don't have access to a computer. So in many ways, this last mile is actually the last 20 kilometers, and it might come from the stratosphere. Project Loon may hold up the entire power of what we're talking about with this network structure. Finally, I want to talk about a couple more topics that are examples of the technologies we're pursuing that are also transformative hugely. If you look at internet access, internet was invented in the United States. What's the average speed in the United States compared to the rest of the world? Well, we're at number 13 on the list. So, that's not really so exciting. Why is that? We have huge population, lots of money, lots of everything. It's not clear to us. So we've said, well, how good a product could you build if you just went out and bought parts off the shelf, put them together to deliver the fastest service possible? Turns out we can go 100 times faster than current products do. So people in Kansas City feel like moving to Kansas City to get fast internet access. So there are cities fighting with us to be the next city, the next county. And the thing is, anyone could have this. All Americans could have this already if whatever structures prevent technology from advancing weren't preventing it in happening in terms of telecoms. Also, I'd like to talk to you about a video now, and I'm going to talk while it's on. There's an element that we do when we work with governments that has to do with the way we at Google partner to help governments exploit their own data. So here's an example with a time lapse we did with the government, federal government, where Landsat data from the history of the Landsat program was used, mosaic together, and then time sequenced, so you can watch growth, say in Las Vegas. You see what the population trends are. You can see fluctuations in the level of Lake Mead. You can see many things that you really couldn't see in the instant you were there, but you can see easily over the perspective of a few decades. Same thing's true for construction in the Middle East, the Palm Islands in Dubai, and all these things. There are things where a different perspective, as Alan Kay said, is worth more than 80 IQ points. And let me leave that now to tell you the following, which is, where does the data come from? You might ask, how does Google get this data? So here's an example. This is a picture of Washington, D.C., and the roads are color-coded. The green roads are going at the rated speed, yellow roads are slow, and red roads are almost stopped. And if you look at that where the arrow is there, it turns out there's some sort of traffic jam between the White House and Congress. And you might say, how does Google know there's a problem like that? And the answer is because people's mobile phones give average speeds. And by aggregating the mobile phones, Android phones of 1 million people in DC, we can get road by road average speeds and reflect that back in the map, guide people in navigation. And it's all done by having every citizen be a sensor. Those sensors could be for moisture, for NBC contaminants, for many kinds of things, ozone levels. And so phones someday will be basically the laboratory people carry around in their purse or pocket to enable whole societies to be smarter and get first alerts when they need them. In summary, I remind you that our mission is serious, and that to do it for the whole world, to really organize all that information, requires so many computers, so much data, so many different kinds of devices. It can't be done on your desktop. The data you need to solve your problems doesn't fit in one server, on one rack, in one floor, and certainly not in one laptop, and not in your pocket either on a phone. It only exists throughout a whole integrated network of devices that all serve you. That's our mission. That's the mission of Google Enterprise and of Google itself. Thank you for your time.
Hey, Michael, appreciate it again, folks. Michael Jones, Google's Chief Technology Advocate, and that is going to close down our Hangout series here as part of Innovation for the Nation, our virtual summit. Fill out that survey for us. We do appreciate your feedback. We will be in touch with some follow-up communications that will tell you how you can reach some of the archived presentations that we will have available for you. And on behalf of the Google Enterprise Government team, again, my name is James Hilliard. Really appreciate you all being here, and we do look forward to talking to you all down the road.